you should copy down these vocab definitions so that you have them recorded in your student journal. So you want to pause the video and take note of these. You can see all those, many of those concepts here in the properties. So I would be highlighting things like the parabola opens up when a is greater than 0 and opens down when a is less than 0. So let's just look at that. Here's a is greater than 0, and the parabola has a curve so that it's opening up. So the opening is in this direction, so it's opening up. That's what that means. And then over here, a is less than 0. The parabola is opening down. So again, the opening is facing in the downward direction. Okay, so that's all that means. We also have learned about the graph getting narrower or wider when we were doing vertical stretches and shrinks. So it holds true for this because it's a function, just like before. If we have a value a in front of x squared, if that absolute value of a is greater than 1, then that means it's going to be a stretch, and so it's going to get narrower. Okay, and then it gets wider, or it does a shrink, when the absolute value of a is less than 1. Now remember, we use the absolute value of a here because negative a just tells us that we're opening down, and positive a tells us that we're opening up. So the negatives have nothing to do with the narrowing or widening of the parabola. All right, and then the next bullet looks a little bit more confusing, but this is something that you really need to take note of. So x equals, x equals negative b divided by 2a. That is your axis of symmetry. So you'll notice in the diagram that the axis of symmetry, just like your vocab word said, it splits the parabola in half and it goes right straight through the vertex. Well, that's very important because if we know what the axis of symmetry is, then we'll know what the x value of our vertex is, and from there we can find our y value. Because the y value is just taking the x value as an input to our function. So that would mean that if we got, let's say, negative 2 as our x value, we would take negative 2 and substitute that into an equation for our x's. We don't put it into c. So our x squared would end up being a 4, and our x would be the value of our axis of symmetry. So this is a very important concept to remember. You need to get this memorized so that you can always use it because it's a very important concept. So where does the a, b, and c come from? Well, it comes from this standard equation. So you only use this when you have it in standard form. So there's your a and your b. And for this one, we don't need the c, but later on we will. So we just take the negative of b and divide it by 2a, okay? And then finally, the last thing that we can find on our parabola as we travel along the parabola, so we found the axis of symmetry, we found the x value of the vertex, and from that we learned to find the y value. We can also find where the parabola crosses the y-axis, because on the y-axis, x equals 0. So if we were to substitute 0 in for x's, the only thing that we would have left is our c value. So then y equals c, which means that we'll have a point, we'll always have a point 0, c. And so knowing that, we know that if we go right along c, we have another point over here that's equidistant from the axis, the axis of symmetry. It's going to have the same distance to this next point. So it'll have the same y value, c, and it will have a value that's equidistant from the axis of symmetry to the next side. Okay, so that's a lot of concepts. So let's see what we can do with all of those concepts. I hope you've taken a few notes on here because these are very important things for you to memorize and for you to know just off the top of your head. On your notes page, I want you to write this problem so that we can practice with some of the information that we just saw. So if we're in standard form, we should recognize this as standard form because we can write just below it the standard form. So we have ax squared plus bx plus c. So we can easily tell that our a equals 2 because we're just looking right above it. Our b equals 4 and our c equals 6. So from this equation, we actually can gather a lot of information about our parabola. Okay, so we're going to use the equation to find our axis of symmetry. So the axis of symmetry equation, remember, is negative b divided by 2a. So that's what we're going to, so we have negative b divided by 2a, so we're going to calculate that first. So we have the opposite of our b, which is 4, divided by 2 times our a, which is 2. So that gives us a negative 1. So now that we have negative 1, we're going to actually substitute it into our equation, and so for our x value, and that way we can calculate our y. So we're going to put negative 1 in here, and just do the math. So negative 1 squared is positive 1 times 2 is just 2. Positive 4 times negative 1 is negative 4, and then we have our plus 6. So we have 2 minus 4, which is negative 2. Negative 2 plus 6 equals 4. So we have a vertex. Our vertex is actually at negative 1, comma 4. Okay, so that's our vertex. All right, so I'm going to clear this board a little bit and so that we can get ready to identify some of the other stuff. Because our A is positive, our A is a positive 2 as we've written over here, we know that our parabola is going to open up. We also can find out our y-intercept by substituting 0 in for our x's. But we don't even have to do a calculation to that, because if you look at it, if x equals 0 in this case, then this term is going to be 0. If x equals 0, then this term is going to be 0. And that's always going to be true when we're looking for the y-intercept. These two terms are going to turn into zeros, and so our y-intercept is always just going to be c. So we have a point, we know that we have a point of 0, c, just as we had discussed earlier. Okay, so we also can find our axis of symmetry, because our axis of symmetry is just the x value of our vertex. So our axis of symmetry, which we abbreviate AOX, is x equals negative 1. So axis of symmetry is actually a line, so we have to say x equals negative 1. We don't just say axis of symmetry equals negative 1. It's very important to put it into this notation, x equals negative 1. And here I've made a little mistake. I put c there instead of the actual value of 6, because we already know that c equals 6. So let's just change that so that we have the right information there. This should be enough information for us to be able to graph our quadratic, because with the vertex at negative 1, 4, we can put our vertex, so it's going to be negative 1, 4. We'll say that's right about there. We have our axis of symmetry that goes through that, and we usually use a dashed line to show axis of symmetry. We have our y-intercept at 0, 6, which is going to be right there. And because the axis of symmetry is a place where it identifies a mirror image, we know that exactly the same distance from the axis of symmetry to this point is going to be on this side. So since that's only one, we know that we have another point over here that's going to be at -2, 6. And so now you can see that we can easily start forming our graph of that parabola. Let's do one more so that we can make sure that we know how to do these. So the first thing that we can find from our standard form is our A, our B, and our C. So let's record those. So we have our A equals 3, we have our B equals -12, and our C equals -1. Okay, so with those, we can then go ahead and we can calculate our axis of symmetry, which gives us our x value for our vertex. Okay, so we have to recall that the axis of symmetry equation is -b divided by 2a. So with that, our b we said was -12. So our axis of symmetry says x equals, and we're going to take the negative of our b. Well, our b is -12. So this first negative does not take the place of the negative in b. We have to take the opposite of whatever our b value is, divided by 2 times our a, which in this case is 3. Okay, so the numerator evaluates out to be +12. So we have x equals +12 divided by 6, which gives us a 2. So the x coordinate of our vertex is 2. We already know the axis of symmetry, so we can write that down, equals 2. Okay, so now with 2, we're just going to substitute that back into the equation. So we have 3, and we're just going to leave placeholders for our x for right now, and we'll put a 2 in there in each of those places. So now we're just going to calculate this to get our y value for our vertex. So our vertex will come out of using the axis of symmetry and substituting it back in. So when we do that, 2 squared, remember we always do exponents first, 2 squared is 4, 4 times 3 is 12, and then we have -12 times 2, which is -24, minus 1. So 12 minus 24 is -12, and -12 minus 1 is -13. So our vertex ends up being 2, -13. Okay, so now that we have that, the other thing that we can figure out is that it's going to open up again because A is positive. And if you think of A being, when A is positive, we're happy and it makes us smile, which means that we're opening up. Okay, so we know that piece of information as well. So it's going to open up. And then we also can find our y-intercept because that is simply just C, and so we have a point at 0, -1. Now we have plenty of information to graph our quadratic equation. We'll be practicing this in class, so make sure that you understand how to use these equations.